Hello dear students, as you all know we are doing chapter number 7 now, alternating current. Today we are going to study about combination of inductor resistor circuit. We are actually doing the different kind of AC circuits. Today we are going to do LR circuit and CR circuit. But before doing that, let me give you a quick review on what we have studied in the last lecture. Because all those what we have studied in the last lecture is going to be used today. Okay. So first of all, about AC circuits, what we have studied. The first AC circuit we have studied, circuit containing R1. In that case, EMF is given by P0 sin omega t, and current is given by I0 sin omega t. When we talk about the phasor diagram, since both have same phases, it will have what? E and I at the same angle from the x-axis, and that angle is what? Omega t. Okay. Then the second circuit what we have studied, it was L only inductor. Okay. Then in that case, EMF was E0 sin omega t. Current comes out to be I0 sin omega t minus pi by 2. Means current is lagging behind by angle pi by 2 with the voltage, that is the EMF. How the phasor diagram was? The phasor diagram of circuit containing only L, EMF is in this way. If this is 0 omega t, then current lies behind omega t with an angle pi by 2. Behind EMF with an angle what? Pi by 2. So this will be the phasor of current. Okay, current lags behind the EMF or voltage. And the last we studied was capacitor only. Okay, in that case, EMF was E0 sin omega t, but the current was given as I0 sin omega t plus pi by 2. Okay, omega t plus pi by 2. In this case, the phasor diagram is given as EMF somewhere here with an angle omega t. Then current leads the EMF by an angle pi by 2. Means current is ahead in phase, and this will be ahead in phase by an angle what? Pi by 2 with the EMF. What is the angle current makes with the x-axis? The total angle is given by omega t plus pi by 2. Okay, so this is what we have studied yesterday. We have also studied graphical representation, but today no graphical representation is going to be used. But these phases you must remember. Okay, in order to proceed. Now let us proceed. Now we are going to study combination of circuits. Here we have got three elements. One is resistor, one is inductor, and the other is capacitor. Okay. So what we are going to do? We are going to study different kind of AC circuits which contains a combination of two of them. Okay. So first of all, let us study fourth circuit of AC, and the fourth circuit is LR circuit. LR circuit. What is LR circuit? L means inductor, R is resistor. How the circuit looks like? So first of all an inductor, and then a resistor, and the both are connected in series. This is an AC source. This is your AC source. This is your inductor. This is your resistor. Okay. So how this alternate? What is the source voltage? Source voltage V is equal to know that in series combination what happens? The current, whatever it is flowing, I should not show the direction because the direction of alternating current changes continuously. But in series combination, current remains same. Current remains same, but the voltage differs. Okay, voltage differs, but the current remains same. Right? So what I am going to study? I am going to study the circuit with the help of phasor diagram. With the help of phasor diagram. Just see how. Let us draw the current first of all. Say this is your current. Current is I. This current remains same, passing through the inductor and then the resistor. For resistor, there is no potential, there is no phase difference between the current and the voltage. So for resistor, the voltage drop is denoted along the current only, because for resistor there is no phase difference between current and voltage. But for inductor, if you remember, for inductor, just I have told you also, for L, if EMF was E0 sin omega t, then current was I0 sin omega t minus phi. Means in inductor voltage leads, EMF leads the current by an angle pi by 2. Current cannot be changed because they are in series combination. Whatever current is flowing through L, the same current is flowing through R also. But what we have seen, what in case of inductor happens, that the current lags in voltage with an angle pi by 2. So this current passes through the inductor also, right? So where will be the voltage of inductor? The voltage of inductor will be somewhere there. Make an angle 90 degree with this. So this is going to be VL. VL is what? VL is voltage across inductor. Now we have two voltages, VL and VR, and they are rotating vectors. So what the resultant they are going to have? So for resultant, what I am going to do? I am going to use parallelogram law. So for parallelogram law, let me remove this statement. This statement is very obvious. For parallelogram law, I am going to draw a parallel line to VR on the head of VL, and then I am going to draw a parallel line to this here. So we are going to have something like this. Okay, so this is our parallelogram. So what is the resultant of this vector VR and here? The resultant is going to be this. So this is R. The resultant voltage V. Okay, the resultant voltage V. The resultant voltage makes an angle omega t with the x-axis. So this angle, the whole angle, is what? Omega. And now voltage and current, they are not in same phase. So this is phase difference between the current and the voltage. Okay? This is the phase difference between the voltage and the current. Right? So from phasor diagram, from the phasor diagram, what we are able to see that V is equal to the resultant voltage, which is equal to what? It is going to be under root VR square plus VL square. In place of VR, what we can write? We can write I square R square. In place of VL, we can write I square XL square. Okay? So now, if I can be taken common, we are going to have I under root R square plus XL square. Okay? What is XL? XL is inductive reactance and W is so XL is inductive reactance. If you remember, XL is equal to what? Omega L, which is also equal to 2 pi L. Yesterday we had studied. Okay. So R square plus XL square, from here if the value of I is to be calculated, it is going to be what? V upon under root R square plus XL square. Okay. So this is the value of current. Now if we compare this formula with the traditional one, that current is equal to voltage upon resistance, here the role of resistance is played by under root R square plus XL square. So this is called impedance of the circuit. Impedance of circuit. Basically what it is effective resistance. It has the same role as the resistance has to play in direct current circuits. It obstructs the flow of AC. Okay. So impedance is represented by Z, and Z is equal to what? We have under root R square plus XL square. Okay. From here, if this phase difference phi is being asked, then how will you calculate? Also, tan phi is equal to what? For tan phi, this right angle triangle. For tan phi, this is your perpendicular, this is your base. The length of the perpendicular is VL and the length of the base is VL. We can write VL upon VL. Now VL can be written as I into XL, and VR can be written as I into R. I and I will be cancelled. We are going to have tan phi is equal to what? XL upon R. From here we can calculate the value of phi also. What is phi? Phi is the phase difference between the voltage and the current. Who leads here? Voltage leads the current because V is here, I is here, and the difference between their phases phi. So tan phi is equal to what? XL upon R. And from here, one very important figure is there, and that figure is called impedance triangle. Just see, if I draw a right angle triangle, justifying that relation. If this angle is phi, so according to that relation, this side should be XL and this side should be R. Okay? Perpendicular for base. In front of phi is perpendicular to base. Then what will be the length of hypotenuse? Length of hypotenuse is going to be under root XL square plus R square, which is R side. Okay? So this particular thing is called impedance triangle. A right angle triangle with sides represents impedance of the circuit is called an impedance triangle. So this is what the whole thing about series LR circuit. Okay? Series LR circuit. How we have done it? Let me repeat. The first thing we have done, made a circuit, write the resultant voltage. Since for series combination current is same, so we have made first of all current. Then for a resistor, there is no phase difference between the voltage across the resistor and the current. The voltage across the resistor is made with the same line, and VL, since I lags behind the voltage of the inductor, so VL leads the current by angle pi by 2. This angle is pi by 2. Okay, so we have two now, VL and VR. The resultant of these must be equal to V. We have used parallelogram law, and then from figure we have got this one, V under root VR square plus VL square. This parallelogram law. Okay, this is a parallelogram, basically which is a right angle. Okay, so for diagonal of it, we can write VR square plus VL square. We have kept the value, we have calculated the value of I. We have got I is equal to V upon under root R square plus XL square. Now this is the rule of resistance, which is called impedance of the circuit. Okay. and it is given by W square plus XL square. And also there is a phase difference of phi between the voltage and the current. So what we have done, we have calculated the value of phi also, and from that figure, from that relation, we have draw a triangle which is called impedance triangle. So this is all about LR circuit. Okay. Now we have to proceed and we have to do CR circuit, capacitor resistor circuit. Now let us understand the fifth circuit, and the fifth circuit is CR circuit. C stands for what? C stands for capacitor and R stands for resistor. Okay? C stands for capacitor and R stands for resistor. Now let us try to understand, let us try to solve it. How the circuit will look like? For capacitor, all you know that this is a capacitor, and for resistance, this is your resistance. This is your alternating source. Okay? This is your AC source. This is your capacitor. This is your resistor. What is the voltage we have? Voltage V is equal to what? V0 sin omega t. That is, this will be equation number 1. Okay. Again, the same logic. If they are in series combination, then what will happen? Current should remain same. Current should be same through C and R as they are in series. Okay? Common sense. If they are in series and current remains same, let us try to understand the whole thing with the help of a phasor diagram. Okay? So current remains same. Let us draw the phasor of current first of all. So this is your current I. For capital resistor, again, the voltage across the resistor is in the same phase with the current. So VR should be in this direction only. Okay. For capacitor, what happens? For capacitor, if V is equal to V0 sin omega t, okay, so current was given by I0 sin omega t plus pi by 2. Okay, plus pi by 2. Basically here, the current leads the voltage by an angle by 2. So in other words, we can say voltage lag behind the current. So if current is this in this direction, then voltage must be in this direction. Okay? This is your VC. Now just see, VC, the current is leading the VC by an angle what? Pi by 2. Okay? Current is leading the VC by an angle pi by 2. Now we have two voltages, VR and VC, and their resultant must be equal to this, because voltage across C is VC, voltage across this is VR. When we add both of them, we must have V. So it is a vector, it is also a vector. For adding vectors, what we do? We draw a parallelogram method. So this is not a straight line, let me draw this thing. Okay, so this is parallel to this, and from parallel to this, I am going somewhere there. So somewhere here we have got. So this will be our resultant voltage V, and resultant voltage makes an angle what? Omega t. Resultant voltage makes an angle omega t. Remember, okay? And this angle between current and voltage, it is given by phi. Now the whole thing we have to calculate again. Current passing through, the impedance, and the value of phi, and then after we draw impedance triangle, right? So for this circuit, we have got V is equal to what? V is equal to under root V VR square plus VC square. So V is going to be what? It is going to be I square R square plus I square XC square. What is XC here? The XC is in capacitive reactance. Okay? XC is what? XC is what? It is capacitive reactance. Its value is 1 upon omega C to 1 upon 2 pi XC. Yesterday we have done it. Okay? I can be taken as common. We are going to have pi under root R square plus C XC square. From here the value of I comes out to be, the value of I comes out to be what? It will be V upon under root R square plus XC square. Okay, so this is the value of I. Now from the same logic, current should be equal to voltage upon resistance. Here that impedance of the circuit, impedance of the circuit, impedance of the circuit is given by what? Z. So here the impedance of the circuit is what? It is under root R square plus XC square. Okay. So this is the value of impedance. Now also we have what we have to find out? We have to find out tan phi. What is tan phi here? Tan phi is perpendicular upon base. So who is playing as the perpendicular here? This side and this side is what? BC. And base is what? VR. So you must write what? BC upon VR, which can be written as I into XC or I into R. Now I and I will be cancelled out. So they are going to have tan phi is equal to XC over R. Now if you justify this relation and make a triangle, then triangle would be like, so this is the angle phi. In front of phi, perpendicular should be there, XC, and the resistance should be there as the base. So this is the base. What will be the hypotenuse? Hypotenuse will be under root XC square plus R square, which is equal to what? Z. So again, this triangle is going to be your impedance triangle, right? One confusion may arise in your mind that in what manner I am going to, how I am able to write DL in the previous derivation. It was I into XL, and here BC is equal to I into XC. I have told you yesterday that's why I am telling you that the lectures are very important. You must see them in a continuation. I have told you yesterday that voltage, that XL plays the same role as the resistance plays in the circuit, right? XL plays the same role as the resistance plays in the circuit. So V is equal to IR is nothing new for you. So V is equal to I into, when in case of inductor we should write I into XL. Same goes with VC. Okay, VC is equal to current multiplied the resistance offered by the capacitor, and the resistance offered by the capacitor to the AC is given by what? XC. XC is what? Capacitive reactance. XL is what? Inductive reactance. Okay? So that's why they can written as V is equal to IR in form of that. For inductor we can write IXL, for capacitor we can write IXC. If you put the value of XL over here, then it will be I into omega L, and for VC it should be I into 1 upon omega C. Okay, so this is all about circuit containing C and R. Right? Now we are going to do the combination of all three, that is the LCR circuit. Okay. The combination of L and C we will study later on in LC oscillations. Today we are going to study the combination of all three. And all three means we are going to study LCR circuit. Okay? Let me remove all this. LCR circuit we have to study. Let us proceed over. So sixth circuit I am going to study, and we are going to discuss that is the LCR circuit. LCR circuit. Now from the name it is very much clear. Now in this what we are going to study? We are going to study combination of all three. So first of all inductor, then a capacitor, then a resistor. Order doesn't matter. Okay, you can connect anyone before, anyone after, no problem. So this will be your AC source. This is your L, this is your C, this is your R. Okay, voltage across L is VL, voltage across C is VC, voltage across R is VR. The source voltage, what we have been provided is V is equal to V naught sin omega. Okay, now let us try to understand about current. For understanding the value of current, you must draw the phasor diagram. Okay, combining all. Let us draw. Since they are in series combination, then current must be same. So let the current be here. And the current is what? Current is I. So this is your current I. For resistance, there is no phase difference. So for resistance, VR is here only. Okay. In case of inductor, the current lags behind the voltage. So voltage leads the current of inductor. Let this be VL. Okay. And in case of capacitor, what happens? Current leads the voltage. In other words, voltage lags behind the current. So for VC, we have somewhere here. Now from the phasor, it is very clear that VL and VC, they are opposite in directions, and we have to calculate the resultant of VL, VC and VR. So what we are going to do? We are going to calculate result for resultant of VL and VC first, and then we will add VR to that. According to the diagram, what I have made, it is very much clear that VL is greater than VC. So we have a resultant in this direction, and that is VL minus VC. Although it can be in the reverse also, like VC is greater and VL is smaller. So in that case, the resultant will be downward. Okay, so VL minus VC is somewhere here, and now VL minus VC and VR, they are the two vectors we have to write. So if we use parallelogram method, so the resultant is going to be this. So this is going to be resultant voltage V. Okay, and now the resultant voltage makes an angle what? Omega t, and the angle between voltage and the current is going to be phi. Okay, so this is the phasor diagram of the LCR circuit. Now we have to calculate the value of current from this phasor. How it is going to be calculated? So V comes out to be what? Under root VL minus VC whole square plus VR square. Okay, let us put the values of voltage. It is VL minus VC whole square plus VR square. So in place of real, what we can put? We can put I into XL. In place of BC, we can put I into XC whole square. Plus in place of VR, we can put IR. It is going to be I square R square, right? Now we can take I out of the root. So under root we are going to have XL minus XC whole square plus R square. Now just see, if BC would have been greater, then in place of XL minus XC, we would have XC minus XL whole square. So since it is whole square, it doesn't matter which is greater, whether XL or XC. The answer is going to be same only. So you can remember this formula from both the cases when VL and VC both are greater. But in that case, when VC is greater than VL, then obviously this phasor diagram is going to be changed. In case of this VL minus VC, we have to make somewhere here VC minus VL, and then in that case the resultant will be in this direction. Okay. From here the value of I comes out to be what? It is V upon under root XL minus XC whole square plus R square. So this is the value of V. If this is the value of V, then what is the impedance? Impedance of the circuit. Impedance of the circuit, which is given by Z, it is equal to whatever we represent the denominator. It is what? XL minus XC whole square plus R square. Okay. Now, also we have to find the value of tan phi. So for tan phi, also tan phi is equal to what? Now this time this works as a perpendicular, and this length is what? VL minus VC. So it is VL minus VC upon base is always VR, we have V. Now if we solve it, we are going to have IXL minus IXC upon what? I into I is cancelled from everywhere. We are going to have tan phi is equal to what? XL minus XC upon R. For this case, if impedance triangle has to be made, then what parameter is going to be? This angle is phi. So now the tan phi formula is this. Now if you draw an impedance triangle for this, so this angle is going to be of phi. According to this relation, this side must be equal to what? This side must be equal to XL minus XC. This side must be equal to R. So this side comes out to be what? Perpendicular base, perpendicular square, XL minus XC whole square plus R square, which is what? Which is the impedance. Okay? Total circuit, total load of the circuit. So this is all about the LCR circuit. But what is happening, let me tell you. In the next video lecture, I will start with this formula. I is equal to V upon the root XL minus XC whole square plus R square. So if you have not understood this formula, from where it has come, you will not be able to understand the next lecture. So this all lectures should be watched, must be watched in the sequence. You should start right from the lecture number 1. If you directly watch lecture number 5, you will not be able to understand a single word. Okay? Maybe words you can understand, but you will not be able to understand the single concept. Right? You have to start right from the chapter number 1 and then watch all the lectures in the sequence. Okay? Moreover, in the next video lecture, we will start with this and we will more study, we will more explore this LCR circuit. Okay? A very important thing is, for better audio experience, please use headphone or earphones. Okay? Because there is some echo. Okay? And you must use earphone in order to have a better audio experience. So this is all for the day. Thank you.